celebration of this great event. The impact on Western culture has been profound. It didn't impact any other cultures. Rather remarkable, and I'll mention just a little bit about that. Particular confluence of events and people and so forth in the West. Astronomy is basically the origin of all modern science. I keep saying this and waiting for somebody to try to shout me down who actually knows what they're talking about. Hasn't happened yet. I'm reminded in this venue as a 9-year-old driving up from Terre Haute to Chicago to go to Adler Planetarium, and I had a flashback when I walked in here this afternoon to look at the audio-visual at these seats. I was very excited. We got there early. We had to leave really early to get there early, but anyway, we were sitting on the steps. I remember being so anxious to go inside, and the first thing we did was go into the sky show, and after 5 minutes, I was dead asleep in those chairs. So I understand. These first slides are a little bit dense, but I just want to set the stage a little bit. Astronomy is first and foremost a subject that depends completely on data that we don't produce. I mean, we can capture it, we can put it in computers and so forth. We can't do experiments, we can't build stars in the laboratory, as you're well aware. There are only a very few ways we can obtain information from outer space and therefore obtain information about the universe. We have starlight, of course, which can also be radio waves and gamma rays and so forth. Every once in a while a meteorite falls. We had one fall in somebody's bedroom a few years ago up in Chicago. That's a little bit rare. It's a scary event. There are cosmic rays, very high energy particles that were discovered in 1911 that are penetrating the Earth all the time. And as a member of an amateur astronomy club told me when I gave this talk, he says, you forgot about sample returns. We're going to comets and meteorites and the moon and so forth and bringing back those samples. It's really not much information. You really appreciate theory when you realize how hard we have to work to connect the little dots of real data that we obtain. These machines are extremely expensive, not by comparison with battleships. We could build many telescopes for the cost of a single battleship. But in terms of the discretionary money that the government has, the machines are very expensive, and astronomers, the coin of the realm in astronomy is telescope time. It's given out in hours. It's extremely expensive and extremely rare, and we don't have many of these machines as a result. The most interesting thing about the devices that we use is that they are based on technologies that have nothing to do with astronomy. That is, they came to us serendipitously from wars, from research. You'll hear a little bit about that during our talk. So it is truly remarkable that we can even get this data. And the creation of these devices was not driven by astronomical research at all. Now we're limited in what we can know. We're limited in many ways. I'll just mention a few, and I'm sure you'll come up with many more. Many physical phenomena simply could not be known to us if it were not for these serendipitous technologies which have come into our hands. Black holes, neutron stars, supernovae, dark energy, many things we just simply wouldn't know about because they only manifest themselves in ways that we cannot sense with our human eyes. Had it not been for other kinds of telescopes, we wouldn't have this information. With regard to the Sloan Digital Sky Survey, I've done a little survey of the papers that people have published from the survey of 200 million objects in the universe. And my conclusion is that after all is said and done, you need about 10,000 objects to truly characterize a population. And I was thinking of how you grow up, how many adults you might run into in your first year. Most of them you won't remember, of course, and then as you get older, you remember before you've encountered 10,000 people. And until you get to college, you really don't know much about human nature, as many of you probably can attest to. So it is in astronomy. We've spent years doing, drawing wide conclusions based on 100 objects or 50 objects of some category. Now astronomy is exploding. There's lots and lots of data. We still don't have 10,000 of almost anything, and therefore I maintain we don't really know much about the universe. We're connecting incomplete pieces of data with theory, and much of it will certainly turn out to be wrong. We're limited because phenomenon that we have nothing to do with learning about just comes to us. The war brought to us nuclear reactions, which of course led to a revolution in nuclear physics. We've learned about dark matter completely by accident. We've learned about dark energy, all buzzwords, which I won't say much about, but I'm sure you know about them. The discovery of planets in 1994 shouldn't have happened. I know the guy who did it. It shouldn't have happened. And we weren't really prepared for it, frankly. It was quite a shock. So we always have new information coming in while we're over here making up our theories about the little bit of data that we have. And the last thing I'll mention, or one of the last things which particularly interests me, is that we haven't looked at a single object long enough with modern detectors to really know how things change. Therefore, we're building theories that are static theories. If you tried to build a static theory of a 3-year-old, you'd be wrong, in a month or 2 years or whatever. So in that sense, we don't understand really what's going on. Sunspots is a good example of that. They famously went away just after Galileo discovered them and went away for 70 years. You'll understand the possible impact of that had things happened a slightly different way as I go through my talk. And then the theories that we have about the data may change. Kant is a wonderful example of a man who looked at the sky or looked at the catalogs of the sky and thought a completely different thing than anybody had ever thought, even though everybody was looking at the same data. So there's some component here of our knowing things because of an accidental flash of insight. Einstein is another person like that. So we're limited, and we can never assume that we really know everything that's going on in any sense. And this is a nice example of that. This is 3 rings that were found in the nearby galaxy called the Large Magellanic Cloud. Just this object, which I'll talk about in a second, just reached the point where these 3 rings appeared as the Hubble telescope was repaired and we had sharp images. A wonderful accident, again, of history and scientific equipment. After many years of study, scientists have deprojected those rings and think that it probably looks like this. I'll talk about the little purple belt at the middle, and then there are 2 red rings on the outside. You can't see the fill-in on this screen, but there's a web of dust and gas that connects these things. This is a supernova, and nobody had ever seen a supernova like this. This is 1990, and we've been studying supernovae for years. Supernovae are the basis for our knowledge about dark energy, but we don't know all about supernovae yet. This is a picture of that purple ring. The little white dot in the lower right at the top of all the images is a star, so forget about that. These are time-lapse pictures, one every year, taken with the Hubble telescope. And you see what happens as you get up. This starts in 1992. As you get up to 1998, 2000, little bright dots start appearing all across the ring. Now, this is many astronomical units away, many Earth-Sun distances away from the center of the supernova. We don't understand really why those lights are lighting up. There are lots and lots of detailed theories, but we only have one object. We'll have to wait for another one to see if we can make predictions. So in that sense, things are always occurring that we hadn't anticipated. So I have this quote from Sir Arthur Eddington, one of the great astronomers of the last century, who said, you have to think about this a little bit. Theories are like balloons floating on the surface of the sea, and the facts are like battleships. Occasionally a balloon collides with a battleship, and the battleship goes down. So that's very much the spirit of what I'm going to talk about. Now, a telescope is a long tube. There's a nice example out in the patio, the gold one that looks at the sun. It has an objective, or a primary mirror, primary piece of optics. It has a back end that we call the focal plane, and we put instruments there. This whole thing I call a telescope system, and I'm not going to develop all these. I have in blue the ones I'll say something about. But an observatory sits at a place either in space or on the ground. It's embedded in an environment which is detrimental to almost all collection of data, and you have to correct for it. There are backgrounds in the sky from astrophysical objects that we have to worry about. That's just the situation when you build your telescope. Then you've got to collect and focus the light